Hey everyone, it is Math Crush Monday. Welcome back. We are talking tonight on the algorithms, on the standard versus a traditional versus a shortcut. There's so much to talk about. So if you were joining me, I would love to know, just say hi and let me know where you're tuning in from and what algorithms you teach in your grade level. Maybe let me know what grade. That'll help me. But this is kind of a hot topic, and the more you can engage and comment or like or anything in the post, and lets me know I can keep going, that we're doing well, that you're here, someone's watching. But this topic I have to battle over and over and over again, no matter where I'm at, who I'm talking to, because algorithms are kind of just a hot topic. People think that you should teach them. Some people think that you shouldn't. Some people think that Math Expressions teaches them too soon. Some people think they teach them too fast. And so there's just a lot to kind of unpack here with what we mean by algorithms. And specifically, the thing that I talk to teachers the most about is this idea of the standard algorithm. And when do students need to have it, whether they're in first grade or they are in sixth grade, and how do we follow that line of progressions? So what I'm going to do right now is I'm going to take us to PowerPoint here. Okay, standard algorithm. The first thing you need to know is that we're all misinterpreting that. Okay, so standard does not mean traditional. Standard does not mean shortcut. Standard means a repeatable method. Okay, so repeatable. So standard algorithm specifically is, it says in mathematics, an algorithm is defined by its steps and not by the way the steps are recorded in writing. The algorithm is based on place value decomposition. That is the definition. So there are multiple algorithms for teaching our students addition. We teach them the expanded. We teach them show all totals. We teach them show to all totals below, all totals above. We teach them several different examples of how to do double-digit addition. And we introduce that in first grade, and then we continue that work in second grade, so on and so forth. Right? So an algorithm is just a recorded method. It's recording the steps, and the steps specifically have to be based on place value. Okay, so that's what I want you to substitute in here. So if we were to take, for example, the fifth grade standard, I like how Christopher Danielson had reworked the standard. So it says fluently multiply and divide whole numbers using an algorithm based on place value decomposition. So if you replace or add to the word algorithm based on place value decomposition, then it helps you know, oh, what does this really mean? So if we're going to multiply multi-digit numbers, it's not, do I know all the steps and to put a placeholder of a 0 and to bring my arrow down, drop down, or all those things that we say to kids. It's not about that. It's, do you know the place value understanding of what we're doing with those numbers and how we break up the numbers, and that we're really multiplying parts of numbers, which is what decompose means. We break down the numbers and we multiply the parts, and then we put the parts back together. That's the end game for everything. Addition, subtraction, multiplication, division. Right? So then if I took it this fourth grade one, it says fluently add and subtract multi-digit whole numbers using an algorithm. Now add the next part based on place value decomposition. Okay, so it's not, oh, my kids need to be able to multiply or need to add and subtract multi-digits just with the algorithm or the shortcut or the traditional, right? It's no, their method must be based on place value decomposition. Okay, so I'm going to add to that here. Sorry, I'm getting messages galore. Standard. So let's talk about the standard part. So that's a little bit about algorithm. Now I'm going to talk about standard, and then I'm going to kind of blend them to you for every grade level. Okay, so standard. This is what the NBT, which is the numbers in base 10, the learning progression says. Now, the learning progression, my friends, is what tells us how the math is built from kindergarten through 12th grade. It's a progression document. It does not matter which state you teach in and which standards you have. Okay, the learning progression document is just is. Okay, it's how the trajectory of learning. What different states did, including the Common Core authors, is they took the learning progression and they chopped it up, and they said, okay, we're going to take this first part and we're going to call that first grade standards, and this next part we're going to call second grade standards. So they wrote the progression about how math develops, and then they broke it up into standards. Different states decided where those markings went. Right? So some people teach rounding in second grade. Other people don't teach it till third grade. So the Common Core standards teaches in third grade. Most states follow that, but other states that don't it doesn't really matter. Your standards are still very similar. All your standards. There's just little nuances. So here's what it says here. I want to plant this idea here that standard algorithms are for base 10 computations. They, yada, 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 yada. And it narrows it down to these single digit computations. All of this is the 4 operations rely on decomposing numbers based in base 10, properties of operations, collect single digits. So one could argue, though that's what the whole excerpt from the learning progressions mean, one could argue that the standard algorithm then is not just an algorithm where we've kept track of our numeric steps because we've broken down the numbers, but it's specifically the standard algorithm is one that can get broken all the way down to single digits. Okay, so that for many of us would be known as the traditional algorithm or the shortcut. I still feel like there's some interpretation there, and you talk to some of the big math gurus right now in the country and they will disagree and not even say it has to get down to single digits. Okay, so I want you to focus on this. An algorithm must be based on place value, bottom line. Okay, and some students are going to use one written method and it works for them, and as long as it's based on place value, it's generalizable, which means it's something that will still work even when our numbers get large, because some of the methods our kids have don't work long term. Like that when the numbers get too big, it's no longer efficient. Okay, so whatever their method is, it has to be generalizable. So if it meets those criteria, technically they're meeting the standards. So now let's talk a little bit more. The traditional algorithm, when people say, oh, hey, they have to do the standard algorithm, many of us think that means, oh, it's the shortcut method, right? But remember, the standards say standard, they doesn't say traditional. We just all think that. So when it says in our standards, hey, students need to know the standard algorithm, we think, oh, that must mean the shortcut. That's not what it means. Okay, so we want to look here. I just want you to be clear. In the United States, here are our shortcut methods or our traditional methods. So these should look like, for all the different operations, the things we all kind of grew up with. Okay, the shortcut doesn't mean the right one. This is just one of the algorithms. But I hear all the time from teachers, well, but 5th grade needs us to do that because they have to. No, they don't. No, they don't. We just don't understand our standards. So let's make decisions based on what our standards actually say. So let me show you that real quick. I promise you'll start making sense here in just a minute. So now let's look here. There's methods and there's algorithms. Okay, so in the learning progressions, it talks about the methods. So notice these are more like kind of our mental math strategies. The methods and strategies could be argued that they're different, but for this sake of argument, we're going to say that they're the same. An open number line, it's counting on, it's tracking our steps. But these would be considered methods, not necessarily algorithms. But for every grade, we do something like this, and then we connect it to a written numeric algorithm, because the standards say they do have to have a numeric method. Okay, so a written numeric method, which would be called now an algorithm. So these are all the algorithms for every grade level for whatever you teach: addition, subtraction, multiplication, division in math expressions. Now, other curriculums have other ones they've added in. These ones, though, if you look in the learning progressions, you would see in the actual document for everybody, you'll see these methods. So remember, it's because, oh, you can't see what I'm doing. Here's, okay, so these are all the methods. Sorry about that, friends. And then here's the algorithms, right? So we're connecting the methods to an algorithm. So we start here because that's the kind of the intuitive strategies that kids come up with. It's their mental math strategies. And then we say, okay, now we need to formalize it. It's our proof drawings. We're going to formalize it into more of a numeric method, right? And so we do have to have a numeric method, but let's look at each one. Multi-digit addition. Okay, here's what I need you to know. They do not need to know the standard algorithm, which means get it all the way down to that single digit, maybe any of these. Let me go back, this one. Okay, so here's our addition. They don't have to have one of these down pat they can do with total procedural fluency until the end of 4th grade. They must have in 1st grade, in 2nd grade, and in 3rd grade, they must have place value understanding. So if you look here in 1st grade, it says use place value understanding and properties to add and subtract. Use concrete models, drawings, strategies based on place value. Use operations, use a relationship, use a written method, okay, to explain their reasoning. So in expressions, we're going to introduce those 4 different methods or those 4 different algorithms, and students should stay where they maintain place value. So the drawings don't go away. The secret code cards don't go away, because their standard is not about can you do an algorithm. Their standard is do you understand the place value. Okay, so now we go to grade 2. Grade 2 is the same thing. We take what we did in grade 1 and now we add to it. We add 3-digit numbers now. We do proof drawings, secret code cards, concrete models. But if you read this carefully in the standard, nowhere does it say standard algorithm. Nowhere in here. We've just made that up. Okay, so if you have students that really understand show all totals because they understand that 34 is 30 plus 4 and 68 is 60 plus 8, and they'd rather add their 30 and their 60 first, and that is maintaining place value understanding, and they can do a proof picture to match, they just met their standard. They do not have to go all the way to the shortcut method. Now, could they? Yes, but only if they understand place value. So some of us think the end game is the shortcut method, carry the 10, which some of us say carry the 1. That's your first red flag, right? So we think that is the end game. That's not the end game. The end game is being able to add multi-digit numbers fluently based on place value. So we stop them on the algorithm progression wherever it is that their understanding breaks down. So if they do the shortcut method, but they can't tell you for their life that 1 that they just put up top is actually a 10 and it came from regrouping the ones, they don't get to stay there. They need to go down to another algorithm where they maintain place value understanding. In expressions, it is a progression of difficulty. It goes from concrete to the abstract, but you don't have to go at the same pace math expressions does. When it introduces 2, you don't have to do 2 methods in one day. By no means do you need to do that. You can space it out because now you understand the standard. Then you get over here to 3rd grade. Look, they're the same thing. Fluently add and subtract within 1,000 using strategies and algorithms. Okay, so this is algorithms using strategies. Okay, even in 3rd grade, our end game is not the shortcut. It's not the standard traditional method. It's just not, right? 3rd grade is not there yet. We still want to make sure, do they really understand what those numbers mean? Because now we're going into thousands. And now kids need to understand that they really did make a new group of 100. We made a new group of 1,000. We need a new group of 10. But sometimes we forego that because we're like, just carry the 10. Well, it's not a 10, actually, now it's 100. Okay, so when we say our kids don't have number sense, this might be why. So we rush too quickly to some of those shortcuts because we think it's our standard. It's not. It's not. Okay, then look in 4th grade. Fluently add and subtract using the standard algorithm. Now, we can all argue about what standard means. We're going to say, for the sake of tonight, that it's one of those 4 methods I just showed you. Okay, show all totals, new totals above, new totals below. So I guess 3 different methods. Okay, one of those by the end of 4th grade. So then we get to subtraction. Okay, multi-digit addition, subtraction, same thing. It's by the end of 4th grade. They need to understand ungrouping, that we are not borrowing, we are ungrouping a 10, so we have enough to subtract. There's 3 different methods for that. They need to have formalized one of those methods by the end of 4th grade. Should I teach it right at 2nd grade when I have kids barely holding on to what numbers are? Probably not. Could some 2nd graders totally get it and see the relationship between the initial algorithms and that one? Yes, I don't have a visual, sorry about that. But 2nd grade, I want to maintain understanding. So my end goal is not the shortcut method of cross out the 3, mark it a 2. That's not the end game. The end game is place value, understanding what it is. So proof drawing and methods and a written method that supports that. Then you get to whole number multiplication. Okay, so look at this quote. Multiplication moves from the first year in grade 4 with multi-digit. 3rd grade, you don't do multi-digit for most states. Where the approach of the standard is developed using visual models, diagrams, which is the area model. 4th grade, your standard says they have to know the area model. They don't have to know the shortcut, so stop it. Use partial products, right? It's way more based on place value. And then they go into 5th grade where now, because they understand so deeply how to decompose numbers, they can use the algorithm smoothly. So in 4th grade, if we really spent the time of knowing how to break up double-digit numbers and how to multiply a 10 times a 10 and a 10 times a 1, when we get to 5th grade is like, you've been doing this for a whole year. Are you ready to see how it connects to even a shorter, more efficient method? Then they can introduce a shortcut because kids have had a whole year under their belts versus us rushing through unit 4 in 4th grade, rushing through it just to get to the shortcut, and we sacrifice place value for that. Let's not do that. Lastly, let's go to the next couple. I have division and then fractions. Okay, so I'm going to come here. Oh, no, wrong thing. There we go. Division. This one's going to be a shocker. The standard algorithm for multiplication, end of 5th grade. The standard algorithm for division, that whole dumb, my dear Aunt Sally brought over beer, I don't know, whatever the saying is, bring down, subtract, multiply, divide. whatever, that digit by digit method, that would, for some people, it's considered standard. I'm going to just call it one of the methods. I would never teach it to my kids ever because I think it's so abstract. But if kids want it, or otherwise they can do expanded and they can do the place value sections. But they don't have to have a formalized method for that, one that they will do with ease, including very large numbers and double digit divisors till the end of 6th grade. So what if we all just took a chill pill in 5th grade and just taught what place value understanding meant with long division, and then we formalized it in 6th grade? That's where the standard's at. Now, it's in your teacher's guide. Why? Because it's one of the methods we should introduce. Kids should be able to work fluently with it. Are all kids ready for it? No. Can they see it and say, oh, look, it's the same as this one, and see connections? Yes. Do they have to go practice it and master that shortcut? No, they don't. All right, last but not least, we have decimal multiplication division. Okay, here's grade 5. Grade 5, they multiply using multi-digit whole numbers using the standard algorithm. They add, subtract, multiply, and divide decimals using concrete models, drawings, strategies based on place value, and they have a strategy they can relate it to a written method. Nowhere in here does it say they have to have that shortcut method or even a standard algorithm. They need to understand what it means to multiply decimals, and we're going to do that with tools, drawing strategies, and connect it to a written method. I think you should do partial products and area model. That's what I think. Grade 6, now they're responsible for those standard algorithms. Fluently multiply and divide numbers using the standard algorithm. Fluently add, subtract, multiply, and divide decimals using a standard algorithm. And the, I guess, controversy out there is it the standard algorithm or is it a standard algorithm? I'm going to go with a standard algorithm. A standard algorithm, something that is repeatable, something that is generalizable, something that's based on place value, and something that is written in numeric steps. That's my suggestion. So my friends, let me come and see how we are doing. So tell me in the comments something that you're like, you could totally disagree. Because some of us have been teaching this for so long that we're like, those 3rd graders need to know, right? And it's ingrained in us. But if we really take a deep look at our standards, we'll see, I think we might be misinterpreting it. Not only are we misinterpreting the phrase standard algorithm, but I think we're misinterpreting what it means when we say they have to be able to multiply and divide or add and subtract. Well, using what methods? And are we focusing on place value? So let me know in the comments what you think. I think this will help you just to take a deep breath. Some of us are just plunging forward. I think some of us plunge forward because it's what we know. It's just easier, like, oh my gosh, just teaching the shortcut, let's move on. This whole like area model thing is killing me. But actually the area model is part of the standard, right? So if you're someone that's like, I'm doing it because it just feels easier, then I would love to welcome you to come to the Math Genius Squad, because I will teach you in videos how to break down those each one of those concepts so that your students really get it. And more importantly, you really get it. And then you'll be like, oh my gosh, why haven't I taught it like this throughout my whole life? So the shortcut only feels easier because it's what you have done for years. But it's not easier to a student who hasn't ever seen it before. They need concrete understanding. So if you're struggling with that, remember that my Math Genius Squad right now is open. I will teach you via video all of those things. So if you need help with that, you just reach out to me. If your district is struggling with this idea, or we have to do it because 6th grade says we have to, or 4th grade says we have to, reach out to me. You can send me a DM. I'd be happy to do some professional learning with you to really dive into these standards more and just to learn the progressions ourselves so we can teach them better. So my friends, just know your standard. Now every state is different. So you could look at your own state standards and create an argument of, but in our state we have to, and it might be different for your state, but based on the learning progression documents and what I've outlined here in the Common Core standards, I just want you to be clear so that you can take a deep breath and focus on number sense. Because the number one thing everyone says their kids don't have, number sense. No matter what grade you teach, that's what I hear. So this is how we fix number sense. We base everything based on a place value visual model. All right. I hope it was helpful. It's a quick overview. We didn't dive deeply into any of the methods. I know that was a little vague. If you're interested in those, you can put them in the comments. Otherwise, come join my Math Genius Squad and we'll see you guys online. Thanks, everyone. Bye-bye.